Hey, everybody. Thank you so much for joining us today for this week's PAVE virtual panel. We are going to get started very shortly. And before we get started, I just want to share a reminder that you will be able to find the full recording of this panel as well as all of our previous PAVE virtual panels on our website at pavecampaign.org or on our YouTube channel. Just search PAVE Campaign. So, I want to welcome you all to PAVE's 139th virtual panel. Today, we are going to be talking about AVs and work zones. So, this feels very timely for me living in the Midwest because as it's warmed up, we are seeing more and more road construction every day. So, I'm excited to dive into our conversation today. Our panelists are John Miller of Nexar, Chris Posh of Teledyne FLIR, and Catherine Rios from Prepass. My name is Caitlin Magny Miller. Many of you know me. I'm the communications director at PAVE, and I will be moderating today's discussion. And before we dive in, I want to give our panelists a chance to introduce themselves. So we'll start with you, John, and then if you can each give us a bit of a background on yourselves and what you do, that would be great.
Yeah, sounds great. Caitlin, thanks so much for hosting. Really excited to be here. So my name is John Miller from Nexar. I'm our Chief Business Officer. A little bit about Nexar. So we focus on real-world intelligence. And the way that we do that is we have a pretty large network of AI-powered dash cams. We have over 350,000 AI dash cams that are distributed throughout the US. And the way that we've built our technology stack, all the way from the hardware in the cameras to the firmware, the software, is everything is built to extract intelligent information from the roads that would be relevant for departments of transportation, autonomous vehicle companies, or really any stakeholder that needs to understand what's happening on the road in real time. I think today's discussion and the topic of how work zones play into the role of departments of transportations being ready for AV readiness and AV deployments is really timely. To me, the biggest difference between work zones and other types of road assets, think signage, potholes, any other thing that you might need to see on the road, is that work zones are constantly changing, right? So if you think about a stop sign, the chances are that stop sign is going to be there, you know, for the long haul, right? Stop signs are not changing overnight. Work zones are changing in some cases by the hour, by the day. Sometimes they're being removed or replaced. Sometimes the nature of how they're set up are being changed. And so it's extremely critical that departments of transportation have close to real-time visibility into those work zones, and the changing environment of those work zones poses a real challenge, especially as AV deployment continues to rapidly increase.
Thanks, John. Chris?
Yeah, thanks, Caitlin. My name is Chris Posh. I'm the Director of Product Management for Emerging Technologies at Teledyne FLIR. We design thermal cameras and perception systems for robotic applications such as advanced driving systems or robotaxis type situations. And I'm fortunate enough to work with several robotaxi companies and vehicle manufacturers, getting them to understand how to use thermal imaging. I love the technology. It's such cool technology. And I work with several tier ones, and specifically Vallejo. They are a major tier one supplier for vehicle manufacturers. And they are fortunate enough to have all the different sensor modalities. So for example, LiDAR, visible, thermal, radar, and get to work with companies to, each sensor modality has their own strengths and weaknesses and decide which is the best system for different vehicles. And in my opinion, thermal imaging is one of the best sensor modalities for robotic systems that need to see people and animals in any condition. But again, every sensor modality has its strengths and weaknesses, and it's really neat to work with the various different companies and show them thermal imaging.
Amazing. Thanks, Chris. Catherine?
Yeah, hello. My name is Catherine Rios. I am the product director of bypass compliance, safety, and innovation at Prepass. And what we're really interested in this entire ecosystem is consuming work zone data, right, from a variety of different partners, and then distributing that to the CMV, whether it's a human operated CMV or an autonomous truck. We know that the more visibility and awareness into work zones, the better, right? We can slow down the vehicle, we can change reaction times, and that saves lives. So that's a little bit about me, and thank you for having me. It's very exciting to be here.
Great. And now, as we dive into our discussion here, Catherine, I'm going to stick with you with this opening question. Before we get into really AV specific topics, I'm wondering if you can kind of set the stage for us on the current state of work zone safety. What are the biggest risks or the biggest trends that we're seeing today for drivers, workers, and these roadway operators?
Yeah, great question. So I think there's really two stories here. One is a positive and optimistic story, and then the other is still quite a sobering story. So let's start with the good piece in that we have engagement and activity really from all sides. So from the federal government, state DOTs, the tech ecosystem, and research institutions as well. So at the federal level, construction workers, work zone workers have been designated as vulnerable road users. So now we have federal dollars going to protect them, right? At the state level, we have 23 out of 50 jurisdictions participating in the work zone data exchange program, which is huge. On the tech side, I would say that virtually every OEM and TSP is participating and thinking about safety alerts. We have vendors doing amazing work like Vermac and Haas partnering together to push digital work zone alerts straight into driver dashboards. And then on the research front, we see a number of research institutions participating, like the University of Cincinnati, Purdue, and even more. So I think that's the good part of the story is that everyone that needs to be engaged is engaged, and this is top of mind. So now shifting to the flip side of the coin, 850 people were killed in work zones in 2024. That is a decrease over 2023, and I don't want to minimize that. This metric is in lives, so every single decrease is meaningful and positive. Um, but that's still 2 deaths every single day in work zones, and so we can do better. We all want to do better. And while we're seeing fatalities at scale come down, we are seeing fatalities related to speed go up. And so what I would say just to sum up this response is that we're seeing a lot of progress. We're seeing progress on volume, but we haven't quite yet seen that behavior change at scale that we want to see.
Really interesting. But exciting to hear about some of this emerging technology and research that's happening as well.
Yeah.
John, I want to turn over to you here. Data obviously plays a really important role in understanding and navigating these work zones. Given your role at Nexar in collecting this really large scale and real world driving data, what are you seeing in terms of how work zones are operating in practice? Are there patterns or sort of common challenges that stand out?
Yeah. Well, first I want to piggyback a little bit onto what Catherine was mentioning around what are the actual consequences of this state of work zones in the US today. Um, I think Catherine, you mentioned 850 deaths in 2024. I believe it's like that's 100 deaths down from 2023, but it's still a very real safety issue. And so I think we're hearing a lot from Vision Zero teams, for example, that they're making a lot of progress in reducing the amount of fatalities and accidents in their respective jurisdictions. But work zones continues to remain a blind spot because of the dynamically changing nature of how they operate. Um, Beyond safety, there are other consequences or missed opportunities for departments of transportation as well. Um, Beyond safety, there's congestion, right? If work zones are set up in a way that they're bleeding into the street more so than their permit allows them to, then it's going to cause traffic. And we all know the downstream consequences of having too much traffic. There's also lost revenue opportunities for departments of transportation. And what I mean by this is when departments of transportation don't have a strong understanding or a good enough sense of visibility into whether contractors are actually operating within their permits, whether they're operating, whether they even have an active permit, and if they do, are they operating within the geographic constraints of the permit, or are they operating, at night when they're not supposed to be? Um, if a Department of Transportation doesn't have visibility into this, they can't enforce any action. They can't issue a fine. They can't send an inspector out to issue a warning. And the implications of this is that they can't hold contractors accountable, and they can't collect on revenue that they otherwise would have been able to and reinvest that back into safety initiatives. So there are real consequences that we're seeing from our stakeholders across the departments of transportation. And so back to your question around how does data play into this? One of the benefits that we have at Nexar is given how large our network of cameras is we're one of the only sources of data that can actually detect change and give DOTs that real-time visibility into whether a contractor is operating within their permit in a timely manner. And so I think that's the biggest difference between work zones and other types of assets that DOTs need to have visibility into. And I think it really stresses the need to be able to understand what's happening with work zones in pretty much real time.
Absolutely. Chris, I'm curious to get your perspective from a sensing and perception standpoint. What makes work zones particularly difficult for these AV systems to navigate? How do factors like maybe low visibility or temporary signage impact sensor performance? And what advancements in sensing technology are helping to address some of these challenges?
Yeah, exactly. Good question. Work zones, they stress perception systems, and lane markings can disappear or not be standardized. It gets even harder when there's dust, glare, rain, or it's nighttime. So that all that variability makes this particular corner case even harder to solve. I think one thing that really can help this type of situation is sensor diversity. Instead of having just like one sensor that's just seeing visible, for example, or maybe just visible on radar, I think that sensor diversity or sensor fusion, things like adding thermal, will definitely help these types of corner cases, these complicated situations. Fusing thermal with visible and radar, these are types of things that would help in these particularly difficult situations, these corner cases, which the hardest things to do is get these corner cases solved. And that's, I think, you just need to have more data.
Yeah, great points. Now, Catherine, given you are coming to us with a more freight and highway operations perspective, how do work zones impact vehicles traveling at highway speeds? What sort of unique challenges do they introduce for both human drivers and automated systems in that case?
Yeah, I think there's two real risk factors that we think about. The first is speed compliance, and the second is what we call end of queue. But starting with speed compliance, we know that CMVs have been involved in 30% of the fatal work zone crashes. And of those, speed was a factor in 34%. And so when we think about a work zone, imagine a lane. Lanes can be compressed down to 10, 11 feet in a work zone. And when you consider that a CMV is 8.5 feet wide, we are now talking about inches of a margin of error, right? And so in that scenario, speed is not our friend. And research at Purdue has found that without automated enforcement of speed, only 25 to 50% of vehicles complied with the posted speed limits. So I think that's the first thing. The second thing would be end of queue. So meaning it's the back of a traffic jam where free flowing traffic from the highway is suddenly meeting stop vehicles. Obviously, this is an issue in work zones. And when we consider a CMV, again, whether it's human operated or autonomous, we're talking fully loaded, roughly 40 tons. And at 65 miles per hour, the FMCSA would say, hey, guidance is about 525 feet to stop. That is 2 football fields. So giving drivers seconds to respond to that situation, it's not going to work. And sadly, we see that in the data as rear end crashes represent 21% of all fatal work zone crashes. So what I would say, and John and Chris have both hit on this as well, is that both of these risks, speed compliance and end of queue detection, are exactly what connected data and automation are positioned to solve really well. The other good news here is that we know that data and early warnings work. So we've seen research out of Texas that deployed end of queue warning systems on I-35, and we saw a 44% reduction in crashes. So that's the good news.
Yeah, the data speaks for itself. That's really impressive. And kind of building on that, John, thinking a little bit more broadly here, what role can infrastructure, whether that is physical or digital, play in improving how AVs are navigating work zones? Are there opportunities for better coordination between roadway operators and these vehicle systems?
Yeah, I mean, I think the way that I would think about it is like, first, how do we define infrastructure? It could be interpreted or defined in so many different ways. I would put it into three buckets. Like the first bucket of infrastructure is the objects and assets that are actually on the street, so signage, work zones, things of that nature. The second bucket of infrastructure would be the physical sensors, whether it's cameras in a vehicle or cameras on the side of on a red light camera, or LiDAR or any other type of technology, physical sensors that are out out in the field. And then the most important, which is digital infrastructure. And I think that's the long pole in the tent when it comes to departments of transportation adopting the digital infrastructure that's actually required to scale and be ready for mass market deployment of AVs. Ultimately, coming back to the permit example, a city, I think New York City issues over 1,700 construction permits per day. And they don't have any digital infrastructure in place to actually understand if the contractors with those permits are operating in compliance with the terms of the permit. And the way that New York City handles it is they actually have manual inspectors that are going out into the field to inspect 1,780 permits per day. That's obviously not a scalable solution. And so departments of transportation, especially as AVs begin deploying at scale, really need to be able to have infrastructure that allow them to understand where these work zones are. Are they operating in compliance? One of the things we're doing, we actually just launched a partnership with IBM and their Watson X Orchestrate team, where they are taking our curated work zone detections that we have been providing to departments of transportation for years and adding an additional layer onto it where their agentic systems are going into our imagery and cross-referencing them with the permit databases to actually provide departments of transportation insights into not only here's the work zone, here's what it looks like, but here's information as it relates to how it's actually in compliance with its permits, and here are the actions that you can take. And so I think ultimately adopting this type of digital infrastructure is needed now because once the majority of vehicles on the road are AVs, it's going to be a requirement. It's not going to be a nice to have.
Really interesting. And And also just putting in perspective those number of permits, the 1,700 permits issued every day, really, really puts into perspective how dynamic these work zones are and how much they can change, just day to day. Um, Chris, obviously, unlike standard roads, work zones are relying heavily on things like temporary signage, cones, barriers, a lot of moving pieces there. How challenging is it for sensor systems to interpret these sort of non-standard cues, and what improvements do you think could be made to make those easier to navigate?
Right. Right. So temporary elements or construction zones they're harder because they don't have standardization, and so a cone may be so totally different than a fixed site where it's not a construction site and it's all standard. So because machines or machine vision relies on learned patterns, and so I'd say inconsistency increases uncertainty. So improvements can be had when you design construction zones maybe with higher contrast materials or include like thermal aspects so thermal cameras can see the construction zones better and basically remove some of that inconsistency. From a sensing side, object classification over like visible, thermal, radar, that all helps reduce uncertainty and as like I said before, has more data to make better decisions. And so thermal cameras in this particular situation, they can allow the systems or the cars to see the road cones and the barriers, regardless of the lighting condition. And I've seen these construction zones quite often. They're doing this at night and have bright lights and huge spotlights, and this makes it very hard for just a visible camera system to navigate those types of situations. So thermal cameras are not affected by glaring lights or they can see through fog. So it adds thermal cameras would add more data in these types of situations, and those people that are in those working in those work zones, they just basically glow. So that I definitely think thermal cameras can help this particular corner case.
Yeah, absolutely. John, we've kind of already touched on this, but curious if you have anything to add. Of course, work zones are changing day to day, maybe even hour to hour. Um, how important are real-time data and map updates in helping automated vehicles operate safely in these environments? And what gaps are still in place today?
Yeah, I mean, I think this continues to be a real challenge for AV companies that are already in deployment, already in operation. One of the things that we see from our customers is they've trained their routing and navigation systems to navigate away from work zones when they know where they are, because as Chris mentioned, they are
Oh,
real.
they just avoid them.
They avoid them. I mean, they're a real corner case. They're really difficult to handle, and when they have the visibility into understanding exactly where they are, it's safer to avoid the situation entirely, especially if it only takes a minute, 30 seconds off of their route. Um, and so, obviously, to that end, understanding when the work zone is put in place and then understanding when it's no longer there is super important to updating your routing and navigation systems. With that being said, it's obviously not a scalable solution just to completely avoid work zones at all times if you're an autonomous vehicle company. And so on the other side of it, one of the most common, the other part of Nexar's business is that we actually capture video of work zone interactions, real humans driving with dash cams navigating around all types of different work zones. And our partners in the autonomous vehicle ecosystem use this video footage to actually train their models to be able to handle and navigate around those work zones. And so I think there's no naivety around the fact that autonomous vehicles need to learn and understand how to handle these difficult types of edge case scenarios. And we're seeing it in real time because one of the most uh, predominant needs for training is training on corner cases that involve complex construction sites.
Absolutely. Kind of on the other side of the coin here, Catherine, successfully navigating these work zones is not just a vehicle problem. It involves obviously infrastructure, policy, human behavior. Where do you see the biggest gaps in coordination across these stakeholders today?
I think there's two. I think first the data layer and adoption of the data layer specifically is still a bit patchy. And then secondly, I think we still don't really have codified policy around how AVs should specifically behave in work zones. And that makes sense, right? For all the reasons that John and Chris just explained. This is a complex edge case that the industry just didn't tackle first, right? And that made sense. So in terms of the data layer, so we have the work zone data exchange, which was built to push real-time work zone data into vehicles, right? It's a great concept. It's been very successful, but we only have 23 of the 50 jurisdictions that have adopted it. So if you're thinking about a truck that's operating over the road in multi states, what that could mean for them is that in one state they have great awareness and visibility into work zones and what's coming, and then they cross state lines and suddenly they have no visibility and awareness into it. And in R&D, we worry about that a lot because it creates an inconsistent user experience. So what I would say is data availability results in an inconsistent driver experience, whether it's human or autonomous, and that's problematic. So then going on to the second one with no codified policy, um, there are questions that we need to hammer out, right? So how does the AV respond to a flagger? What if the HD map doesn't match the actual cone layout? What's the required speed threshold? What are the best colors or finishes on the road markers to be picked up by the AV's camera sensors? Things like that. But again, I think the good news is that there's a lot of research and testing that is happening. And so I would call out the University of Cincinnati, who's partnering with Honda and the Ohio DOT to look exactly at these types of things. And I think that research, as well as the R&D testing from companies like Kodiak and Aurora and Torque and so many others, will just help inform that policy so that we get it right.
Yeah, absolutely. It's good to hear, many of PAVE's trucking partners called out there as doing some good work in that space because obviously it's very impactful to them as well. Chris, turning back to you, from your perspective, how close do you think we are to AV systems really confidently handling work zones in real world deployments? And what do you think still needs to happen to get there?
Well, I think so far they're doing a pretty good job, but systems can obviously get better. I think when visibility gets poor, this can get even harder of a problem. So you need better sensor robustness and perception systems. And I'll give you an example because there's actually two corner cases. One is work zones, and then the other is driving at speed. You talked about that, Catherine, going at speed. You need more range. Well, what do you do when you're driving at speed, say 70 miles per hour, and you're a truck? You need a long ways to stop, and there's a work zone coming up. Well, so a sensor or a self-driving truck is going to have visible cameras, but at night, at range, they're not going to see anything because those headlights are going to go, let's just say 50 meters or maybe even 75 meters, but they're not going to go 100 meters or 200 meters, which is more like the range you need at speed. So then it's also going to have radar and or lidar on the car or on the vehicle, but that's going to be fairly difficult at that range because of number of pixels or sensing on target. So what we're seeing is some of those trucking manufacturers that you talked about, their corner case of traveling at night when it's dark, coming towards, for example, a work zone. How do I see 100 to 300 meters? That's a very, very hard corner case because you need to see 1 to 300 meters with some type of sensor at night in order to slam on the brakes and not blow past all of these work zones. So that's why we're seeing thermal imaging being a good sensor for those types of situations because it can see 200, 300 meters at night in these challenging situations and therefore mitigate a potential catastrophe. So some of those companies you mentioned definitely are looking at or using thermal for that particular corner case.
Yeah, definitely an important edge case to address. Unfortunately, I had a couple more questions, but we are out of time. I want to thank you so much, John, Chris, and Catherine, for taking the time to join us today. Like I said, we are going to post the full video recording of this panel on YouTube. So search us at PAVE Campaign or follow us on social media to see that as soon as it's released. And thanks to everybody who attended. We appreciate you participating today.
Thanks, Caitlin.
Thanks so much.
Thanks, Caitlin.